Welcome to our deep dive today. We're cracking open, learning to learn, unlocking the secrets of adaptive intelligence 1-hour guide by Anil Nathu.
Sounds intense.
It is, but also super relevant, whether you're, leading a team, starting a business, or just trying to level up personally.
I like it already.
What grabbed me is how it ties machine learning to how we learn, like as humans.
Yeah, that's the coolest part. The book dives into how machines can actually learn how to learn better. It's wild, almost like they're getting meta skills for knowledge, you know?
Right. It's like our brains are constantly upgrading for new challenges.
Exactly.
Okay, so the book uses real-world stuff to explain this.
Oh, yeah. Like what?
Well, they talk about how Amazon's recommendation engine actually uses learning to learn. Pretty mind-blowing. But before we get there, can we back up a sec? Like, what is learning to learn compared to regular machine learning?
Sure. So traditional machine learning is all about finding patterns in data, like teaching a computer to spot a cat in a photo.
Right. Feed it tons of cat pics. It learns what makes a cat a cat.
Yeah, exactly. But learning to learn goes way beyond that. It's like the machine is changing how it learns based
Exactly.
on what it's already learned.
So not just spotting patterns, but getting better at spotting them.
You got it. It's becoming a more strategic, adaptable learner.
Okay, I could dig that. But how does this apply to us? Humans don't just memorize, right? We make strategies, mental models, those rules of thumb based on our own experiences.
100%. That's why we're so good at new challenges. We learn from wins and fails and use those lessons next time. Learning to learn tries to give machines that same power.
I remember a great point from the 1-hour guide by Anil Nathu. They talked about knowledge transfer across tasks, like learning to ride a bike helps with learning a motorcycle.
Totally. Key concept there. The idea is if a machine's already mastered one thing, it can often use that knowledge to learn a related thing faster.
Makes you think about entrepreneurs who apply skills from one venture to the next one.
Absolutely.
Or even just us in our own lives, constantly using past stuff to navigate new situations.
Makes you realize this isn't just making smarter machines, it's about understanding learning itself.
Powerful stuff. Now, the 1-hour guide by Anil Nathu gets into some specific techniques used in this meta-learning thing. Some were honestly a bit over my head initially,
Oh, yeah.
but I think I'm starting to grasp them. Could you give a quick, explain it to me like I'm 5 rundown?
Absolutely. Let's start with multitask learning. Instead of training a model to do one specific thing, you train it to do a bunch of things at once.
Oh, that's interesting.
Like imagine teaching a computer to translate languages, write creatively, and answer your questions all at the same time.
So like taking different classes, they actually reinforce each other.
Yeah, you start seeing those connections you wouldn't if you were just focusing on one thing.
Right, right. So by learning multiple things together, it spots those shared patterns.
And that makes learning way faster and more efficient.
Okay, that one clicked. What about reinforcement learning with self-modifying policies? Now that one sounds complex.
I know, right? But picture a robot learning to walk. Instead of just following a program, it's constantly trying stuff and adjusting based on what happens.
So it's like learning from its own stumbles and getting better as it goes.
You got it. And what's even cooler is the robot can actually tweak how it learns along the way. If one strategy isn't working, it tries something else, always evolving, always getting better.
I'm seeing how this all ties back to learning to learn, right? It's about becoming a better learner overall.
Exactly. The last one I'll mention is neural network reuse.
Okay.
So you're leveraging those models that have already learned stuff. Instead of starting from scratch each time, you adapt an existing model that's learned some relevant patterns.
That's like having a head start.
Exactly.
Right.
Way faster and more efficient.
Okay, so we've got multitask learning, reinforcement learning with self-modifying policies, and neural network reuse. Powerful stuff. But how does all this relate to, our brains?
That's where it gets really interesting. The 1-hour guide by Anil Nathu also dives into the psychology of learning. You know, stuff like schema theory, analogical reasoning, how we recognize patterns.
So it's not just about smarter computers, it's about understanding ourselves better too.
Totally. By understanding how learning works for both humans and machines, we can learn better no matter what we're doing.
And now I'm even more curious about that Amazon recommendation engine.
Right. That's a great real-world example of how these principles are used.
We'll have to dive into that after the break.
Welcome back. We're deep in the 1-hour guide by Anil Nathu, right where we left off, this whole learning to learn thing.
Yeah, and before we jumped off, we were getting into Amazon and how they use it. You're saying they started with basic algorithms.
Right. Super simple stuff at first.
How did it become more, advanced?
Well, they realized machine learning could make their recommendations way more personalized, way more accurate. Data, tons of it. They started gathering everything, what people got, what they looked at, even stuff they put in their cart, and then ditched. Then they used fancy machine learning to analyze it all.
So it wasn't just about what one person did. It was patterns across millions of customers.
Bingo! They found these subtle connections you'd miss otherwise. Like, maybe people who buy a certain book are also into, I don't know, a specific type of music, even though those seem totally unrelated.
Whoa, that's pretty cool. It's like the system is understanding us better than we understand ourselves.
In a way, yeah. But the key is Amazon kept going. They kept tweaking the algorithms, sharing what they learned across different groups of customers, always experimenting.
So the recommendation engine itself was learning to learn.
Exactly. Always getting better, more personalized. That's what makes it such a perfect example of this in action.
And this has implications beyond just selling stuff online, right?
Oh, yeah. Think about healthcare, a system that learns from patient data and gets better at diagnoses.
Or in finance, spotting those risks and opportunities in the market, changing strategies as it goes.
See? Endless possibilities.
Okay, now, the 1-hour guide by Anil Nathu goes deeper, right? Each chapter builds on this.
You bet. There's a whole chapter about knowledge transfer, specifically in neural networks.
Yeah, that was about representational and functional transfer. Sounded a bit technical, to be honest.
It can be, but it's important. Let's break it down.
Okay, representational first, I guess.
Think of it like this. You've got a neural network. It's great at recognizing cats.
Okay, sure.
You can use that to build a network that recognizes dogs. Instead of starting from nothing, you transfer some of that cat knowledge over, adapt it a bit.
So you're building on what's already there.
Exactly. Saves tons of time, makes learning way more efficient.
Makes sense. What about functional transfer?
That's a bit different. Here, the network's learning multiple things at the same time, and it figures out how to share what it learns between those tasks.
So it's spotting those connections as it goes.
Right, like a student taking history, literature, philosophy all together. They start to see how the subjects connect, which helps them understand each one better.
I can see how that would be powerful. Now, you said this chapter also talks about challenges with knowledge transfer.
It does. One big one is catastrophic interference.
Oh yeah, we talked about that earlier. Catastrophic forgetting, right? Where learning something new messes up old knowledge.
That's it. And that's a huge problem when you're building a system that needs to keep learning.
So how do you fix that?
Couple ways. One is incremental learning, where you add new stuff slowly so it doesn't disrupt what's already there.
Like building a house brick by brick.
Good analogy. Another way is to design smarter neural networks that can handle learning new stuff without forgetting the old stuff.
Sounds like a lot of people are working on this.
Absolutely. Cutting-edge stuff in AI research.
Okay, so we've got knowledge transfer down. What else does the 1-hour guide cover?
Well, it dives into the theoretical stuff behind all this. Bayesian statistics, function approximation, all that mathy stuff.
Yeah. Now, that's where I get lost. Can you break it down for us non-mathematicians?
I'll try. Bayesian statistics is about how our beliefs change when we learn new things.
Okay, that makes sense. But how does that connect to learning to learn?
Say you have an algorithm, it's trying to guess if a customer will buy something.
Right.
It starts with some guesses based on old data, but as it learns more about the customer, it changes those guesses, gets more accurate.
So it's constantly updating what it thinks based on what it sees.
That's Bayesian learning in a nutshell.
Okay, and what about function approximation?
Well, it's a way of representing a complex relationship between inputs and outputs. Like imagine you're trying to draw a line that goes through a bunch of dots.
I can picture that.
In learning to learn, we're trying to find a line that captures how learning works across different tasks. Instead of a different line for each task, we want one that works for a lot of situations.
Like a master key for learning.
Yeah, that's a good way to think about it. And the more the system learns, the better that master key gets.
It's all starting to click. Bayesian statistics, function approximation, they all work together to explain how this learning to learn magic happens.
And that explanation is what lets us build even smarter algorithms, push AI further than we ever thought possible.
Right. Now, the 1-hour guide also talks about task similarity. How does that fit into all of this?
That's key because it tells us when it's good to transfer knowledge. If two tasks are similar, transferring knowledge helps a lot, but if they're not, it can actually hurt.
Like knowing how to bake a cake doesn't help you play the piano.
Exactly. So a good learning to learn system needs to be smart enough to know when transferring knowledge will help and when it won't.
Man, this is all making so much sense. I'm really starting to grasp the big picture.
And there's even more. The 1 Hour Guide goes deeper, talking about multitask learning, low-dimensional representations, all that good stuff. We'll get into that after the break.
And we're back, wrapping up our deep dive into the 1 Hour Guide by Anil Nathu. It's been quite a journey through learning to learn.
It has. And, it's bigger than just AI. These ideas apply to how we learn as people, how businesses grow, how we solve problems, you name it.
Before we left off, we were talking about knowledge transfer, that Bayesian stuff, even how similar tasks need to be.
Right. But the 1 Hour Guide keeps going into even more mind-blowing territory.
Oh, good. I'm ready for more.
Chapters 5 through 13, they get into techniques that really push the limits of what's possible. Multitask learning, low-dimensional representations, lifelong learning algorithms, even something called advice-taking reinforcement learners.
Okay, you're going to have to slow down for me on those.
No problem. Let's start with multitask learning. Sounds fancy, but it's something we do all the time.
How so?
Think about it. Juggling multiple projects, wearing different hats, that's multitask learning. The idea is, by learning a bunch of things at once, a machine learning model can spot those patterns that connect them.
Okay, I'm following.
It's like imagine a student taking math, physics, chemistry all at the same time.
Oh, I get it. They start to see how the subjects overlap. Right?
Yeah. Exactly. It makes learning each one easier because you're getting the bigger picture. And the 1 Hour Guide has tons of examples of how this is used in real AI, like in language processing and computer vision.
Cool. Now, what about those low-dimensional representations? That sounds pretty technical.
It is a bit. Think about all the data out there. Images, text, sensor readings, it's all super complex, right? Lots of variables, lots of features.
Right.
But not all of it is useful. Some of it's just noise, and that makes it harder for the machine to learn.
Like trying to find a needle in a haystack.
Perfect analogy.
Yeah.
Low-dimensional representations, they're all about simplifying that data, finding the important stuff, and getting rid of the rest.
So it can focus on what matters.
You got it. And the 1 Hour Guide explains how this can make those machine learning models way more efficient, way more accurate.
Okay, I'm seeing the theme here. It's all about making learning better, faster, smoother.
Right. And that leads us to lifelong learning algorithms. These are systems that are built to learn continuously, like they never stop.
We talked about this before, and it's still mind-blowing to me. It's like creating AI that never stops growing.
It is. They're designed to remember what they've learned, use that knowledge in new situations, and keep getting better as they get more data.
Sounds like the key to making truly intelligent AI, right? The kind that can keep up with the real world.
Absolutely. The 1 Hour Guide does a great job of explaining the challenges and potential of this whole field.
Okay, one more. You said something about advice-taking reinforcement learners.
Oh, yeah, that's a fun one. So normally in reinforcement learning, the AI learns by doing stuff, getting rewards or punishments.
Like a kid learning to ride a bike, right? Falls down, gets up, figures it out.
Exactly. But with advice taking, the AI can get tips from someone else, like a human expert or maybe another AI that already knows something.
So it doesn't have to learn everything the hard way. It can get a shortcut.
Yeah. It can use that advice to learn faster, make better decisions, especially in those really complex situations.
Man, this 1 Hour Guide by Anil Nathu is packed with amazing ideas. We've just scratched the surface, haven't we?
We have, but I think we've hit the main points. This whole idea of learning to learn, it's about constantly looking for ways to improve how we learn, whether it's AI or our own brains.
And that applies to everything, right? Business, personal growth, science, tech.
It's a whole new way of thinking. Learning isn't just the goal, it's the process, too. We need to keep getting better at learning itself.
This deep dive has been a learning experience for sure. Thanks for taking us through it.
My pleasure. Everyone listening, I hope you check out the 1 Hour Guide and see how you can apply these ideas in your own life.
That's great advice. And to everyone listening, thanks for joining us today. Visit the 1 Hour Guide website for more great insights by Anil Nathu.